Hello and welcome to the final lab of the year. This lab we call Distillation. You've done a lot of separations this year. You separated water out from a hydrate in the composition of a hydrate lab. You separated out components of a mixture when you did the CSI lab, separating out components of ink based on their polarity. If you remember, the more polar molecules traveled through the paper carried by the water, and the less polar molecules stayed behind on the non-polar paper. In the lab techniques lab, you did a separation based on the fact that when you've got a solution and you heat it up, the water is going to boil off at a much lower temperature than the stuff that's dissolved in the water, as long as the stuff that's dissolved in water was originally a solid. Okay, so it's not that hard to separate, let's say, a liquid from a solid, but what if you're trying to separate a mixture of liquids from each other? That's where distillation comes in, because all different liquids boil at different temperatures. And if you've got a mixture of liquids and you heat them up, gradually they'll boil off one at a time. So you heat it up and the substance with the lowest boiling point will boil off first and you can collect it. And then the substance with the second lowest boiling point boils off and you can collect that. When you separate a mixture like this, it's called fractional distillation because you're picking off different layers, different fractions from the mixture. Fractional distillation is very handy when you're trying to separate a mixture of crude oil. Here's some crude oil. This is Middle East light crude oil. It's called light crude oil because it's got a very low viscosity, because the molecules in it are generally pretty small. It doesn't have a high tar content, so it's easy to extract from the ground. Well, relatively easy to extract from the ground. And here we have North Sea light crude oil. It's from the North Sea, that's why they call it North Sea light crude. Again, it's called light crude because it's got a very low viscosity. There's a lot of small molecules in here and not a lot of thick, tarry goo. So this stuff isn't all that terribly hard to extract out of the ground. Of course, once you've used up what's in the ground, what are you going to do? It takes, 500 million years to make more of it. Here we have European heavy crude and Venezuelan heavy crude. It's thick, tarry goo. It's a lot harder to extract from the ground, and it's also harder to refine. What do I mean by refine? Well, what I mean by that is to extract the different molecules from it using distillation. So exactly what is it in crude oil that we're trying to separate out through refining process? These. It's called a hydrocarbon molecule because it's a molecule that contains only hydrogen and carbon. If you get a molecule that contains hydrogen and carbon and something else, it's not called a hydrocarbon, it's called something else. This is propane. It's about the smallest molecule you're going to get out of refining crude oil. You get all different kinds of molecules out of this. You get the molecules that are used to make, propane, butane, gasoline, plastics, home heating oil, jet fuel, kerosene, lubricating oils, waxes, greases, everything to the tar that's used in asphalt and also roofing shingles. There's a lot of things you can get out of crude oil. So how do we separate out these components? Well, it turns out that every time you add a carbon onto the hydrocarbon chain, the boiling point increases because the attractive forces between the molecules get stronger. We can use this to separate the molecules out on the basis of how many carbons there are in the molecule. Now, the big tarry molecules are going to have very high boiling points, so it's not going to take a lot of cooling to condense them out and collect them. The medium-sized ones that are used for such things as jet fuel, home heating oil, diesel, and gasoline, these molecules are going to boil at a much lower temperature, which means you've got to cool them off a little bit more to condense them. And really small molecules like butane and propane, they have really low boiling points. In fact, butane is only a liquid at room temperature if it's kept under pressure. And propane, it's only a liquid at room temperature if you keep it under a lot of pressure. Now, since crude oil is fairly volatile and fairly toxic, to do this lab today, instead of using crude oil, we're going to substitute strawberry soda. See, strawberry soda's got many different ingredients. Let's see, we have carbonated water. This is water with carbon dioxide gas in it. High fructose corn syrup and or sugar. That's got a much higher boiling point than we're going to be able to get with our Bunsen burner. So that stuff's going to get left behind as a residue. Citric acid, potassium benzoate, a preservative. Natural and artificial flavors. Those are esters, okay? Basically, they are molecules that give fruits their various tastes. There are specific esters for strawberry flavor. Now, they're naturally occurring esters, and they're the ones we've been able to replicate in the lab. That's why we have artificial flavors. Gum acacia, in case you want to chew your soda, and red 40, because you're not going to find this color in nature. So what we're going to do is we're going to heat this soda up, and we're going to extract various components, one right after the other. The component with the lowest boiling point is the artificial flavoring. You're going to be able to detect that using your nose. The component that comes out next is carbon dioxide. The addition of carbon dioxide to a solution acts to acidify it, as the carbon dioxide combines with water to form carbonic acid. We're going to test for this with bromethymol blue. Now, bromethymol blue is blue in a base, so I've got a slightly basic solution here. But when you add carbon dioxide, that brings the pH down. It acidifies it. And the bromethymol blue will gradually change from green and then to yellow. You don't have to wait for it to get to yellow. As soon as it turns green, you know that the carbon dioxide is being added. Allow me to demonstrate. I'll add some carbon dioxide from my breath. See that green color? That came about because I breathed CO2 into it, and the CO2 acidified my solution. That is what you're going to look for when you're doing this lab. And the component of this that has the next highest boiling point, well, you're just going to have to figure that one out for yourselves. You're going to collect it in a test tube, you're going to take a look at its appearance, you're going to take a look at its boiling point, and you'll be able to determine what the substance is based on just those observations. For this lab, you need the following equipment. This is your distillation column. You've got a thermometer to tell the temperature. The vapor goes out this tube, hits the cooler air, condenses, and then comes out this end. What comes out this end is called the distillate. You'll also need 2 bottles, mostly filled with tap water, one test tube with bromethymol blue, the other test tube is left empty. You will use an Erlenmeyer flask to hold the soda while you heat it, and you will also need a ring stand with a ring and wire gauze, utility clamp, and Bunsen burner. Now let's see how this lab gets done. The first step is to fill up 2 bottles most of the way with tap water. One test tube goes in empty. The other test tube gets filled most of the way, but not all the way, with bromethymol blue, which you then cap back up again. Then pour in 50 milliliters of strawberry soda and place a boiling chip into the flask. Light a Bunsen burner. And one person should smell the tip immediately, shove their nose under the tip, and give a sniff. Now, record the temperature. As soon as you smell the ester, record the temperature that it comes off at, and immediately place the bromethymol blue test tube in there to test for carbon dioxide coming out, so that the tip of the tube is in the liquid. Bromethymol blue is blue at high pHs, and as you lower the pH through acidification with carbon dioxide, the color turns green and then to yellow. You only have to let it go until you start seeing green.
There! Yeah. It's going so fast now.
When the bromethymol blue turns green, remove the bromethymol blue test tube and replace it with the other test tube.
96.2.
When you get drops of clear liquid into your test tube, record the temperature, turn the burner off, and you're done.